For lesson 2.2, there are two major topics. One of them is to find limits as you head toward a very, very large positive number on the x-axis, and as you head toward a very, very large negative number on the y-axis. Now keep in mind that you may end up with a horizontal asymptote for the positive that could be different from a horizontal asymptote to the negative. But whether you have a horizontal asymptote depends on the behavior of the function as you go further and further out. If the function levels out, then you have a horizontal asymptote, and you could have two of them. But it is possible that you could have a lot of variation in the function prior to getting to the extremes. The way to find this is shown with example 1, or rather example 6. For example 6, we want to use the N&M rules anytime we deal with horizontal asymptotes for a rational function. And in this case, x to the fourth and x to the fourth are the same, so 5 over 10, or 1/2, is going to be your horizontal asymptote with that problem. It says VA there, that should read HA. For the next one, the fourth and the fifth, when compared, show that the denominator dominates. Therefore, the denominator becomes a very large number over the numerator, which heads the whole fraction toward 0. On number 8, the numerator dominates over the denominator. Therefore, the whole fraction becomes a huge number, which means you're heading toward infinity. So instead of your function leveling out as you head toward infinity, you're heading up. Because of that, you're going to end up with no horizontal asymptote. Or you could claim that as you head to infinity, you reach infinity, or you could say that the limit does not exist. Commonly, they'll just say there's no horizontal asymptote. For number 9, it's going to be the same approach. We're going to first multiply out the primary factors. 2x times x squared gives me 2x cubed, and x times 3x squared gives me 9x cubed. Don't concern yourself with the numbers that are not going to be controlling the function, such as 3, -1, 2, and -1. Keep in mind the note that you have to consider the highest degree of the terms, not the highest factors. In other words, look at these terms right here and look at the power of those terms in order to come up with the ultimate highest terms. For example, number 13, we're going to let the notation we used up in number 6 be translated into limit notation down here. So we're now heading toward infinity, and because the 3 is relatively insignificant compared to 4x squared, we're going to drop it out, just end up with 4x squared's square root, and we end up with 2x as an absolute value. Keep in mind the plus minus in front of the square root is replaced by the absolute value. Now the x over the x turns into 1. We end up with the absolute value of 2, which is just 2 as your horizontal asymptote. Now also keep in mind we're heading in a positive direction, meaning that the denominator, x, will be a positive number, and the numerator is automatically positive because it's absolute value. On number 14, our last problem, we're going to have the same function, but we're heading toward negative infinity, and in this case, we're looking toward the left. Now that means that using sign analysis, x in the denominator is going to become a negative number, and this value, or absolute value of anything here, will be a positive number. Now because the 4x squared square root turns into absolute value, we know we're going to end up with just 2 over 1. And because we have a negative sign here and a positive sign here, having plugged in very large negative and positive numbers, we end up with a -2. Let's go to the next thing that you're going to have to know, which is finding the limits as you approach a vertical asymptote. And that will be on your next video.